Hello guys, welcome back. In the last video we have seen different ways of measuring distances. Now here specifically we would talk about measurement of length. Okay, now measurement of length, it can be measurement of width or breadth, but then width and breadth are essentially lengths of different sides of an object. Okay, what about measuring diameter of a sphere or diameter of maybe this marker or diameter of the marker or then length of this marker. Then if I take this cap of this marker, I can measure the outside diameter, I can measure the inside diameter, I can measure the depth of inside depth of this cap, correct? So ultimately it is measuring distance between 2 points, correct? When I say diameter, when I measure diameter, that means extreme point here and then exactly opposite point of this marker, of this barrel of this marker, correct? So that is basically distance between 2 points. So it is ultimately distance. Okay, so how do we do that? We can make use of this rule. Okay, now here if you can see, I'll show it here. I have centimeter markings here and inches over here, but then now centimeter is further divided into millimeters, correct? So smallest measurement that I can make with this is 1 millimeter, correct? So now this whole entire length of this marker, if I have to measure with this, what I'll do is I'll coincide 0 with one end of this marker, and then I'll try and estimate where the other end is. I can see that it is 13.8. Okay, but then I'm not quite sure whether it is 13.8 or 13.7. It is definitely greater than 13.7, but less than 13.8. That is what I feel. I'm saying that is what I feel because I'm not quite sure, because I don't know the level of accuracy that I can achieve with this. Okay, but then again, if we assume that my measuring skills or my experimenting skills are very, very good, okay, still this scale which I am using, is the scale accurate? There comes the question about accuracy. Now what is accuracy? Okay, now obviously I measure this length of this marker and write it over here. Okay, it is something 13.8 I'm writing. Okay, I give it to you and you measure with your scale. Your scale says it is 13.8, right? Then which one is accurate? Suppose my measuring skills are extremely good, your measuring skills are extremely good, but then the measurements taken by both of us, I say it is 13.8, you say it is 13.7. Okay, which one is correct? So that will depend on the accuracy of the instrument that we use. So there can be some discrepancies in the instrument, or there can be different levels of skills of the experimenter, correct? Then maybe this 0, you can see 0 is over here. Okay, but then suppose the scale is broken, then what happens? So I don't know whether that broken part, it is broken such that 0 of my first centimeter, it starts exactly at the end of the scale, but then I'm not sure whether it is perfect or not, correct? So that is going to introduce some error in my measurement, correct? So that is instrumental error. Okay, now the error that was caused because of our skills, okay, those types of errors would be personal errors. Okay, now suppose instead of measuring the length of this marker, I want to measure the length of a copper wire, a thin copper wire. Okay, and suppose the temperature conditions in this room change. Okay, initially when I started, my AC was at 17 degree or 16 degree. The room was pretty chilled, and after some time my AC is not working. Maybe there is some power cut or something, and outside it is very hot. Okay, and if I measure the length of the same wire at that point, do you expect the wire to expand because of temperature change? Correct, the wire would expand. I don't know how much it is going to expand, but then again that is going to cause some error in my measurement. So that kind of errors which happen due to change in pressure, change in temperature or something like that, okay, those errors would be called random errors. Okay, there can be some systematic errors. There can be some systematic errors, like there is some zero error in the instrument, correct? So there are various types of errors that can happen. We will be discussing the errors and their effects in the measurement in some later section, but for now let us try and measure the length of this or maybe diameter of this. Okay, so as I said, I can use this. Okay, now this instrument, okay, this measuring instrument, it can measure in centimeters, and the smallest division over here is 1 millimeter. Okay, what if if I coincide left end of this marker with 0 and the right end, okay, it is between, as I said, 13.7 and 13.8. Can you estimate how much it actually is? You don't know, correct? Now that is going to depend on the least count of this, so smallest measurement that you can do with this, correct? If my scale can read, so every millimeter is divided into two parts, so half millimeter is going to be my least count in that case, correct? So then I can see it is 13.75. It is neither 13.7, it is not 13.8, but it is somewhere in between. But again that question arises whether it is 13.75 or 13.76 or 13.77 or something like that, correct? So these problems are definitely going to come. So in that case, what do? We go for an instrument which has got as small least count as possible. Okay, now for that, next step of using this scale would be using something like this. And what is this? This is called a Vernier calipers. Okay, now what is so special about it? It has got two scales here. This slides, okay, this is my main scale, and the other scale, it slides on my main scale, so I can loosen these screws and make it move more freely. Now how can I use it? Okay, now first of all, I'll measure the length of this cap. Okay, how can I do that? What I can do is I can use these two arms. Okay, so I'll just hold it like this and I'll hold it like this. Okay, maybe I can tighten this so that it doesn't move, correct? And then I can measure. How we will measure that I'll show later. Okay, now second thing is I measured length, right? Now I want to measure the diameter. Okay, again I'll loosen this and hold it like this. I'll hold it like this. I can measure the diameter. I can measure diameter here, 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 any place, correct? And okay, so that was about outer diameter. Can I measure the inner diameter? Yes, with this instrument, this is such a wonderful instrument. I can use it to measure the inner diameter of this. How do I do that? I use these two arms. Okay, so what I'll do is I'll just bring them closer and I will hold it like this and take it out, correct? Now this, I'll tighten this and then I'll take reading, correct? Alright, so that was about taking the length and outer diameter and inner diameter using this. What about the depth? Can I measure depth? Yes, I can. Now again I'll loosen this and I'm going to use this side. So what I do here is I just pull it down here till this part touches the bottom of the cap, correct? And now again I'll tighten this and measure this. Okay, now I have told you about the ways in which different measurements can be taken: the outer diameter, the inner diameter, the length, and the depth of this. Okay, how do we actually measure it? How do we calculate the exact value? Now, here, as I said, this is my main scale, okay, and this is my vernier scale, okay. Now, now what is so special about this vernier calipers? Now, if you can see here, I'm going to see this scale here, okay, and this scale is in millimeters, okay. Now, what is 1 millimeter? 1 millimeter is 10th part of a centimeter, correct? So 1 millimeter is the least count of my main scale, okay. Now, what about this vernier scale? Okay, you would be able to see some calibrations over here on this vernier scale, which I'll be showing you in some time, okay. And now, what is so special? This vernier scale may have 10 divisions, okay. And when I completely close this, okay, you would be able to see that those 10 divisions coincide, they match with 9 divisions on the main scale. So suppose I have 10 divisions here, and then those 10 divisions will match with 9 millimeter, okay, 9 millimeter on the main scale. So 10 divisions with 9. If this has got 20 divisions, then it will match with 19 divisions on main scale. If it has got 30, 29, 40, 39, 50, 49. So it will match with 1 division less than that. Now here, let us find out what is the smallest measurement that I can do over here. Now for that we will need the least count. So least count of vernier calipers is equal to, there is a simple way of finding the least count. It is the smallest division or smallest measurement on main scale divided by smallest measurement on main scale divided by number of divisions on vernier scale, okay. Now generally on the main scale the smallest division is 1 millimeter, and number of divisions on the vernier scale, it is 10. So generally the vernier calipers which you will be handling in our laboratory, it would have 1 millimeter divided by 10 divisions, so that is going to be equal to 0.1 millimeter, and that is equal to 0.01 centimeter, okay. But now let us see what is the least count of this vernier. Now see here, you can see the smallest division on the main scale, it is 1 millimeter, right? And number of divisions on the vernier scale, it is 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of divisions on the vernier scale is 50. Now you can clearly see here that 50 divisions are getting, they are matching with 49 divisions on the main scale. So now I'm going to write here smallest division on main scale is equal to 1 millimeter, correct? And what is the number of divisions? Number of divisions, we found that it is 50. Vernier scale, that is equal to 50, right? Then least count of this vernier caliper, okay, least count is equal to 1 millimeter upon 50, and that is going to be how much? It is going to be equal to 1 upon 50 would be 0.02 millimeter. So that is equal to 0.002 centimeter. Okay. So that was about finding the least count of the instrument. Okay. Now what about finding making some actual measurement? Now I am going to measure the diameter of this. Okay. So as I said some time back, I'll just loosen this and hold it properly, firmly here. Okay. I won't press it too hard. Okay. If I try pressing it hard, okay, this will get pinched, and I don't want to do that. Okay. So I'm holding it like this, and I'm just tightening this screw here. Then I'll remove this. Now how do I make the measurement? The zero of vernier scale. Okay, the zero of my vernier scale, it is between 14 millimeter and 15 millimeter. Okay, zero of vernier scale is between 14 and 15 millimeter. So I am going to write 14 millimeter there. Okay, diameter cap. Okay, so main scale reading MSR, I'll write it is 14 millimeter. Okay, now the next part. Now what I'm going to do is one of the divisions on my vernier scale, it is going to match with some division on the main scale. So one of the divisions on vernier scale will match with some division on main scale. So I have to find that out. Now here I can see that 46th division on the vernier scale, it is matching with some division on main scale. So vernier scale reading is equal to 46th division, and now that I am going to multiply with least count of this 0.002 centimeter. I am going to write in millimeter, right? So 0.02 millimeter it is, correct? So it is going to be 46 into 0.02, it is going to be equal to 0.92. So vernier scale reading is 0.92 millimeter. Right? Now the diameter of the cap is equal to main scale reading plus vernier scale reading, and that is equal to, I'm going to add this and this, so it is 14.92 millimeter. Correct? Now you can see here that I was able to measure the diameter. Okay, I could measure this diameter like this. I could use this meter rule, small meter rule. Okay, and I could find that it is something like 14.5 and between 14.5 and 15. Okay, I'm not quite sure, so I have to either approximate it to 15 or 14. Correct? Not even 14.5. But with vernier calipers, I am able to measure it to be 14.92, and that may be fairly close to the true value of this. So is this measurement accurate? The measurement that I did, 14.92 millimeter, is it accurate? I cannot say. The reason is, compared to my ordinary meter rule, which has got 1 millimeter as least count, I have a vernier calipers which has got 0.02 millimeter as its least count. Okay, but if I get some measuring instrument which has got even smaller least count, correct, then I can measure this to as maybe 14.9186 millimeter. Is it not possible? Yes, it is possible. How do we do that? which instrument has got even better or even smaller least count than my vernier calipers? It is something called a screw gauge. Okay, now like my vernier caliper has got two jaws. Okay, I have in my screw gauge or micrometer screw gauge again something, something between the 2 points of which I can hold the object to be measured. Correct. Over there, there is a screw, and there is something called pitch of screw and number of divisions on the circular scale and all that. Correct. Again, over there you need to find out the least count of the instrument, and then appropriate readings you have to take, and then you get your final reading. Okay, now again there is something more. Okay, suppose I am measuring the diameter of this cap over here. If I measure it over here, it may be something else. If I measure it here, it may be something else. So how do I get the exact and proper diameter? For that, I'll be taking a number of readings. Okay, I take multiple readings and take average of that, and then I get some mean value which I can assume to be the true value. The true value I can never know. No one can ever know. Okay, the reason is it depends on the least count of the measuring instrument. Correct, and there is no instrument which can be perfect. Okay, so that is how we measure distances or dimensions in laboratories. That was about measuring length. In the next video we are going to talk about measuring mass, measuring time, measuring maybe electric current. Right? Thank you so much.